I'd like for us to consider the following example. Let's say that we were interested in adding up the numbers 2, 4, 6, 8, and we'll continue in that fashion all the way up until we got to 98 and then 100. So that is 50 even numbers between 2 and 100, and I'd like to add them all up. So what we're going to do to help us with this is we're going to create what is called an index. And my index, I'm going to use the letter K, and I'm going to say that the first term in this sum is K is equal to 1, and the second term in the sum is K is equal to 2, and the third term is going to be K is equal to 3, and so on, until I get up to this one, which would be the 49th term, and then 100 would be the 50th term. So I'm always going to want my index to go up by 1. And what I'll be able to say here is that each term in this sum can be written as 2k, where k is starting out as 1 and then becoming 2 and then becoming 3 and going all the way up to 50. And the way that we'll write this is with what we call summation notation. It is also called sigma notation. And the reason it's called sigma notation is because we are going to use the Greek letter sigma. So this is a capital S in Greek. And you can be pretty assured that every time that you see this letter, you are going to be adding something up. We use the letter S, which stands for sum. And so whenever you see the Greek letter sigma, we are going to be adding stuff up. So the way that the sigma notation works is, let's say, for example, that I gave you the sigma, and then in the bottom, I put the index. So K is my index, and I tell you where I'm going to start. I'm going to start at K equal to 1, and then where I'm going to end. And so maybe in this example, I'll say that I'm going to end at 3. And then I have an argument in there. So maybe I'll use the same argument that I had up here of 2K. So if I see this notation, the way that I would evaluate it is that I start by letting K equal 1. Where does K start? It starts at 1, and then I evaluate the argument. So that would be 2 times 1. Then I increase K by 1, let it be K equal to 2, and then evaluate the argument again. So that would be 2 times 2, and then the sigma is going to tell me to add all of these things up. And I keep going until I get to the end. So K equal to 3 is the top value there, and so I would evaluate 2 times 3. Now this becomes an arithmetic question. So this is 2 plus 4 plus 6, and that adds up to 12. So the sum as K goes from 1 up to 2K is equal to 12. If I consider my previous example, I would be looking at the same argument, 2K, but I'd be starting at K equal to 1 and going all the way up to K equal to 50. So I could write this sum as being, here, the sum as K goes from 1 up to 50 of 2 times K. Now, you saw down here that the way that I evaluated it was just by figuring out what each term was and then adding everything up. Obviously, you could do that with this one, but since there's 50 terms, that would be an awful lot of adding. And what we're going to do is come up with a quicker way of figuring out how to add all of those up. But before we do that, let's look at a couple of examples. So let's say, for example, that I wanted to add up 1 squared plus 2 squared plus 3 squared plus 4 squared. And I want to write this using sigma notation. So if this is going to be the K equal to 1 term, and this is K equal to 2, and K equal to 3, and K equal to 4, I can clearly see that K is inside of each one of these terms. So the way that I would write that is that I want to add up K going from 1 up to 4 of K squared. So I let K equal 1, and then I would take K and square it. Then I would let K equal 2, and I would square it. I would let K equal 3 and square it, and so on. Another example, what if I wanted to add up 4 cubed plus 5 cubed plus 6 cubed plus 7 cubed. And I wanted to write that in sigma notation. All right, well, the k does not have to start at 1. But what does have to happen is that it has to go up by ones. So if I look at 4 going up to 5, going up to 6, going up to 7, that is going up by ones. So I could write this as k starting at 4 and then going all the way up to 7 of k cubed. So we need to be able to take sums and write them using summation notation. We also will need to be able to take summation notation and know what it should look like as a sum. So for example, what if I wanted to evaluate k goes from 3 up to 5 of 2k plus 1? Right, well, let's expand that into a sum. I start by letting k be the first value, k equals to 3, and then I'll evaluate this sum. That would be 2 times 3 plus 1. Then I would add to that, let the index go up by 1. So this would be k is equal to 4, and so that would be 2 times 4 plus 1. And then I let k equal 5, and that gives me 2 times 5 plus 1. Now this is turned into an arithmetic problem. So I think that this is going to be 2 times 3 plus 1, that is 7. And then this one is 8 plus 1, so that's 9. And this is 10 plus 1, so that is 11. And I think that all of those add up to 27. Sigma notation is very valuable when you have to add up a large number of numbers. So if I go back to my previous example, I wanted to know what was the sum as k goes from 1 up to 50 of 2 times k. Now certainly I could expand all that out and add them up. That's not a difficult problem, but it would take me a little bit of time. And so what helps us here is that we have a couple of formulas that will help us add up sums, right? And the first formula is the sum as k goes from 1 up to n of c. And what I'm saying is that c is a constant. So for example, this might be the sum as k goes from 1 up to 3 of 5. So there's no k in there. And let's just think about what this would be. I would start by letting k equal 1, and then I would evaluate this. Since there's no k in there, it would just be a 5. I would let k equal 2, and I would get 5 again. I would let k equal 3, and so I have 3 times 5. And that's not too big of a surprise to see that it's the product of those two things. So if I am adding up the sum as k goes from 1 up to n of c, then that ends up being equal to n times c. So that's our first formula about summations. The second one is that as k goes from 1 up to n of k, and so if you consider that example, this would be k goes from 1 up to say 4 of k. That would be 1 plus 2 plus 3 plus 4. Now it turns out, and we'll see why a little bit later, it turns out that this sum is equal to n times n plus 1 all divided by 2. And let's check that. Over here I've got 1 plus 2 plus 3 plus 4. That is going to add up to 10. What this formula says is that I would take n, which is 4, and then I would multiply it by n plus 1, which is 5, and divide that whole thing by 2, and the top is 20 divided by 2 is going to give me 10. So that's a verification of this formula. Another thing that we can take advantage of is that if I have a sum as k goes from 1 up to n of c times, I'll write it as a sub k. And what I mean here is that this is going to be some function of k, and it doesn't really matter to me what it is. But this constant, let's look at an example. Let's say that I asked for the sum as k goes from 1 up to 3 of 2 times k squared, right? So this is a constant multiplied by some function of k. So if I write out what the sum would be, it's 2 times 1 squared plus 2 times 2 squared plus 2 times 3 squared, which instead of adding all that up, if I looked at it and saw that there was a 2 in each one of these, I could factor that 2 out, and it would be 1 squared plus 2 squared plus 3 squared, which is the same thing as 2 times the sum as k goes from 1 up to 3 of k squared. So if I have a constant times some function of k, I can factor that constant out of the sum. So the sum as k goes from 1 up to n of c times a sub k is c times the sum as k goes from 1 up to n of a sub k. So if I just look at these three formulas right here, and there are a couple of more formulas, but let's just stop for a second and look at these three. I can go back to my original example. My original example is that I wanted to add up k goes from 1 up to 50 of 2 times k. So looking at my formulas, I could write, taking advantage of that third formula, there's a 2 here, so I could write this as 2 times the sum as k goes from 1 up to 50 of k. And now this looks like the second formula, so I could write that as 2 times n, which is 50, times n plus 1, which is 51, all divided by 2. And so in this case, those 2's are going to cancel, and then I would get 50 times 51, which I did on my calculator, and you should check, is 2,550. There are two other formulas that we will take advantage of. That is that the sum as k goes from 1 up to n of k squared is equal to n times n plus 1 times 2n plus 1, all divided by 6. We're going to look at an example of this in a second. And the sum as k goes from 1 up to n of k cubed is equal to n squared times n plus 1 squared, all divided by 4. And where those formulas come from is not obvious at all. And for right now, I'd like to just assume that those are true so that we can look at a couple of examples. So let's say, for example, that I wanted to add up the sum as k goes from 1 up to 20 of 3 times k squared. So that would be 20 terms, and like if I just wrote out a couple of them, that would be 3 times 1 squared plus 3 times 2 squared, and then there'd be a whole bunch of them. The second to last one would be 3 times 19 squared plus 3 times 20 squared. So again, that's not a difficult thing, but it would take a little bit of work for us to figure that out. So if I use that formula that I did in the last one, I could say that the 3 can come out. So that's going to be 3 times the sum as k goes from 1 up to 20 of k squared. And now I can see that it looks like this, where n is equal to 20. So I would get 3 times 20 times 20 plus 1, which is 21, plus 20 times 2 plus 1 is going to be 41, all divided by 6. And so that is a calculator question. And when I calculated that, I got 8,610, and you should certainly check and make sure that that is the case. One last thing that we can take advantage of on sums, and I'll call this the last formula, is that if I have a sum as k goes from 1 up to n of a sub k plus b sub k. And what I mean, for example, is let's say that I had the sum as k goes from 1 up to 3 of k plus k squared. Well, let's just write that out. There's not too many terms. When k is equal to 1, it would be 1 plus 1 squared. And when k is equal to 2, it would be 2 plus 2 squared. And when k is equal to 3, it would be 3 plus 3 squared. And then, because this is arithmetic, I could rearrange things. And so I'll put all of these together, the first terms. That would be 1 plus 2 plus 3. And then if I put the second terms together, that would be 1 squared. That would be 1 squared plus 2 squared plus 3 squared. And then if I wrote this as a sum, it's the sum as k goes from 1 up to 3 of k, plus the sum as k goes from 1 up to 3 of k squared. And I don't think that that's a huge surprise. What it says is that if you are going to add up a sum, you could add up the first thing and then add up the second thing. So the way that that formula looks is that the sum of a sub k plus b sub k is going to be the sum as k goes from 1 to n of a sub k plus the sum as k goes from 1 up to n of b sub k. We'll look at one more example where we would use that. Let's say that I wanted to add up from k goes from 1 up to 50 of k plus 2k squared. So I'll take advantage of this last formula that we looked at, and I will divide it up into two sums. K goes from 1 up to 50 of k, and then the sum as k goes from 1 up to 50 of 2 times k squared. Then I could take this 2 and move it outside of the sum. So it's the sum as k goes from 1 up to 50 of k plus 2 times the sum as k goes from 1 up to 50 of k squared. And then I had those formulas from before, which if I'm adding up just k, that would be n times n plus 1, all divided by 2. And then 2 times the sum for k squared, which is 50 times 51 times 2 times 50 plus 1, which would be 101, all divided by 6. When I did this first piece on my calculator, I got that it was 1,275. And when I did the second piece, I got 85,850, which you should check and make sure that that's right. And when I put the two of them together, I got 87,125 as a sum.